Okay, I've imported our irrelevant variable data. Here we've got a data set with the same y and x1 from the previous bias data set. You might recognize those. And then 100 random variables labeled RV1, RV2, all the way up to RV100. So these were literally random variables. I think I generated these using the random number generator in Excel. And so these should have absolutely no bearing on our y variable. But the point of this exercise is that when we test lots and lots of things, by construction, we're going to accidentally reject some of our null hypotheses. We're going to accidentally conclude that some of the random variables are related to our dependent variable, even when that's not true. So let's add in all of our variables here into our model, all as explanatory effects, including x1, and we're trying to predict y, which we know is related to x1, but not to any of these random variables. We'll select all of our variables here, add them in again as model effects, hit run, and see what we get. Now our R squared, our adjusted R squared, these aren't going to get much better as we add in these random variables, because these really are true noise variables that don't have anything to do with y. But as we poke through them, what we're going to see is that while our p-values for most of them are high and would lead us to conclude that the variables are not related to y, that's not going to be the case for all variables. So if we look at RV1 here, it's got a p-value of 0.21, higher than our 0.05 threshold. We would conclude random variable 1 is not useful for predicting y. Random variable 2 has a p-value 0.3368. Bigger than 0.05, we conclude random variable 2 is not useful for predicting y. But as we scroll down, eventually we're going to hit random variable 31 is the first one that has a p-value under 0.05. And so that one, we would reject our null hypothesis of no relationship between random variable 31 and y, and conclude that there is a significant linear relationship between random variable 31 and y. As we keep on going, we're going to see the same for random variable 35. And just checking my notes here because it's really tricky to see all of these. Random variable 44 was close, as was 39. But let's see, our next one ought to be 57 according to my notes. Yeah, 0.0143, so less than 5%. 64, same deal. And looks like we should have 3 more, 75, 84 and 86. 84 and 86, all of those have p-values less than 0.05. So all of those appear to be significant predictors of y. What this is supposed to illustrate is that there's a danger in testing lots and lots of variables without having any particular belief that they're going to be truly affecting our y variable, our thing that we're trying to predict. As we throw all of these things into our regression equation, it's quite easy for some of them, 1 in 20 or 5% of them, to show up just by random chance as being significant predictors of y. And you can read the information in the module to see what are some of the ways that we could handle this if we wanted to make sure that we weren't making these sorts of mistakes.